So, hello everyone, I'm Pau, working at Roche as a Kubernetes platform engineer. And in this talk, I will explain you why we decided to use Talos at the edge and how was our journey uh, before deciding to use Talos. So I will start with an introduction of what we are doing in Roche and what our team specifically is doing. I will explain you what our platform is doing. Then focus a little bit on, because we, as a platform, we do many things, how we use Talos specifically, and then we will see it in a demo. Okay. So again, I'm Pau. I'm working as a Kubernetes platform engineer, currently in a team that is building a platform for different edge locations, hospitals, laboratories, where we have a Kubernetes cluster and then other teams install their applications there. And today, also from Roche, we have my colleagues Yannick and Julia here. So we will be around today, so if you have questions, you can ask it after the presentation or during the day. So, okay, before starting talking about Talos, let's talk a little bit what we do at Roche. I don't know if everyone of you knows Roche, but we are a company with more than 100 years of history. Also, more than 100,000 employees around the world. We work in a distributed team. For instance, I'm from Spain working there, but we have people like Julia and Yannick working from Switzerland. We also have people in Canada. We have people in China. So yeah, kind of distributed team. And yeah, just a few words about Roche. We have two main divisions. Okay, diagnostic. So if you have ever done a blood test analysis in a hospital, probably there is an instrument done by Roche or managed by Roche behind, and also the software that extracts the data and checks the results. So that's what we do in diagnostics, and then we have the other big division that it's pharma, that it's the one that brings new medicines. Okay, so why we have our team in Roche? So here you have in the right how we were working in the past. So each application that want to provide a new software, what they were doing, they were bringing in the laboratory their own hardware, okay? And once they had the hardware, on top of it, they were installing their logging solution, the monitoring solution, so all the applications that you need to have a production platform. And then once they have that installed, they were installing the application on top of it. So you can imagine in big laboratories that it was not manageable, right? You can have hundreds of applications, and yeah, it's too much work repeating the same work, and it didn't make sense. So that's why our team appeared, right? So try to unify the hardware we were providing to the hospitals, try to unify the platform applications we were using for logging, monitoring, and all platform apps, and then just leave a framework so applications can use it to install their own applications in that edge cluster. So what are we doing? As I said, internal platform team. So Roche decides that they want to install an application in a laboratory. Then if it makes sense to have that application running in the edge, then they bring one of our boxes there. We prepare everything, and once the cluster is prepared, we give them access to the GitLab repository because we're using GitOps. And yeah, it's super easy for them to just install the cluster, just adding in GitLab the Kubernetes resources. One of our challenges is that we are deploying a large number of Kubernetes clusters, so it means that everything needs to be automated, okay? And yes, we are present in laboratories, hospitals, pharmacies, doctor offices, many places around the world. So we have two main components in our product, okay? One, as I said, edge clusters, and then the other one is fleet management. I don't know if you used Rancher, but it's kind of a Rancher RKE2, same structure. Okay, so you have an idea. So what we are doing in the fleet management, there we have a web console, so you can see the status of all your clusters you have. So each application has different clusters, so they log in there, and they see all the clusters, the status, and how is everything. And also there we provide a single instance or web page, so they can just check the logs of all the clusters, in not going to each of the edge clusters, but just in a centralized place. And then for Kubernetes edge cluster, which was the key points there. One is the creation of clusters. Our goal is that non-technical people can create Kubernetes clusters, and to be honest, the final goal for us is that they don't even know that there's Kubernetes behind it, but we are not yet there. We also provide an application deployment model, because as I said, we work with different teams, so we don't want them to install directly using kubectl. We have like GitOps, and we are currently working on that, but we want to force people to work in a specific way, so all different applications use the cluster in the same way. Also, what we are doing is we have automatic upgrades, so just click a button and the cluster is upgraded. And yes, as I said, the platform applications are out of the box. So when you create an edge cluster, you just give us some information, and then by default, we are copying a template, okay? And that template contains all the platform applications, and you just wait 10 minutes, and you have logging, Grafana, you have Prometheus, everything you need, okay? The ingress controller, MetalLB to expose the ingress controller. So you can only focus on the applications. So I said before that it's important for us to have everything automated, but just to give you some numbers, our goal is that we have 10,000 edge clusters at the end of 2027. So it means that we cannot just go in all of the edge clusters and do manual things, because it's impossible. So we have a working solution before Talos, and it was working fine. At that moment, we didn't know what was Talos, okay? So what we were using, it was our own distribution of Linux we have in Roche, okay? Then over it, we were installing RKE2, and the part of fleet management we were managing with Rancher, okay? And we had that in production, and we had more than 10 clusters there. And it was fine, but then we saw that we had some limitations that weren't allowed, and that were a problem if we wanted to scale a lot, okay? One of them is that the update process was difficult. Not all of these components are Kubernetes designed, right? So what we needed to do in the upgrade was to build or prepare big scripts, right? And yeah, in theory, all the operating systems were configured the same way, but as it was a normal Linux, right? So they had their own machine. They were just doing SSH to the machine. They were modifying things. Then we ran the upgrade. It was not working. It was not our fault, it was their fault, but at the end it's time that we are losing, right? So we saw that these unexpected configurations in operating systems was taking a lot of time for us, and also security risks. Like we saw what Talos was doing, and we saw that it was an opportunity for us. So why we built on Talos? We saw that we could bring our platform to the next level. What I need to say, no? If I'm in the TalosCon. So yeah, as I said, here in the right, you can see how it was, okay? So again, first we were preparing the custom Linux distribution, over it the RKE2, and then the Kubernetes cluster. So with Talos it's much simpler, right? You just have Talos. Once you configure Talos, you have there the Kubernetes cluster. So yeah, basic information, but at the end it's one less dependency. It simplifies our life. Some things that were super useful for us when using Talos. It's immutable, right? So it means that we have no longer the problem that people goes and modify whatever they need in the OS. What we are doing is we are only giving people the kubeconfig access, right? The Talos config is something that only the admins are modifying, and we try to not modify it if possible. We try to have standard edge clusters. And then security, yes, less components in the operating system. So the less components, the less places where you can have an attack. Okay, one thing that I like of using Talos is that we can have a local environment close to what we have in production. Okay. In the past, what we were doing, we were using Minikube and Kine to test our applications, and they were working fine, of course. But the problem there is that you only test the Kubernetes part, right? So you test that your applications are working in the version you want of Kubernetes. But using local Talos, what we are doing, for those who don't know, Talos is offering this run Talos over using Docker. So that's what we call local Talos. So this way you can have the same Kubernetes version and also the same Talos version that you have in production. Okay. If you want to use Talos in Docker, there are some limitations. Okay. You cannot do for example upgrades, but for most of the things you will have like same Talos config and you can interact with it the same way. And then for production, I will focus in the next slides on it, but what we are doing there is we are providing an ISO that then the users can use to install it and their clusters in bare metal or VMs. So as I said before, our goal is that non-technical people can install cluster, right? So we try to simplify a lot the process of creating a cluster. So the overview of it is the user create a cluster in the fleet management. This is a console UI, you will see it now. Then when you create the cluster, the user is downloading the ISO based on the configuration he has provided. Then once he has the ISO, we need to go to the edge location and just boot from that ISO and we have the cluster running, okay? So focus a little bit on these steps. The first one is we create a cluster in our console, okay? So what we are doing there is we ask the user to provide basic information first, so cluster name, which will be an identifier, then which type of cluster you want. We had more in the past, but the flavors we support now, the type of cluster is production or development. Development is this Talos over Docker. And then which is the version. Why we need a version here? Because as I said before, we have templates, right? So based on the selection of type and version, then what we are doing in the backend is getting the specific platform applications in a specific version and also getting the specific machine config we want to use. And then there is some things that the user needs to provide us, like network information, IP, gateway, this type of things. So when the user creates a cluster, what's happening in the backend, and I will try to focus just on Talos, but if you are interested in the rest of our stack, please come to me after the presentation and we can explain you with more details how other things are working. But what we have is for that specific version you have selected and type of cluster, production or development, we go to our registry and we get our OCI workspace package, okay? And what we do with that is it contains a lot of many Terraform resources. So how we are applying these Terraform resources? The fleet management, what we have is a Kubernetes cluster running in AWS. That's not Talos. We are only for now using Talos in the edge. So I don't know if you use it, but it's super nice to use. In Flags, there are these Terraform controller, right? So there easily you can execute your Terraform apply without worrying about it. So yes, we have the runners that are created each time you want to do a Terraform apply, and we are creating for each of the edge clusters some resources involved, some secrets we need. We are also creating a project for each of the edge clusters, taking the template we have, and then yes, each of the edge clusters have their own repo in GitLab, so they can add their applications. And also we are creating some Talos resources. Okay. So at this point, which Talos resources are we creating? We are creating the Talos machine secret, okay, and then we are also creating the Talos config. You can do that using the talosctl binary, but there is also the Terraform provider, okay. So here we have an example of what we are doing there, okay. It's as simple as you see it here, okay. And yes, at this point we have the Talos config, but there's no cluster yet. So yeah, I will show you how things are working. I will stop and resume again the presentation. My idea was to do a live demo, but I've checked before doing the presentation, and the internet is not working super fast. So I will use the backup, the recording. Okay. So this is the console we have. Okay. So now there are no clusters, but if we check what we have for this is a fleet management console. Okay. So for instance, we have here 4 clusters. Okay. And each of these clusters, you can see that there is a workspace, there is a GitHub repository where you can install your applications. Okay. So if we want to create a new cluster, what a user is doing is here it's providing a name of the cluster, and what I said, each cluster version is the version you want, and then the flavor is production or development. You will see here we have more flavors, but it is the legacy ones that we are removing. So once the user select that, what we have in the backend is, okay, for that specific version and that specific type of cluster, what information do the user needs to provide to be able to create a cluster automatically? So for instance, we are asking the user which is the type of the target of installation. It's a specific device we are providing. It's a general VM, also the architecture, also the network information. So for this demo, we will create a cluster for using a VM. Okay, the architecture of my laptop is ARM, so I selected ARM, and then yeah, by default we offer some network parameters configuration that are working in most of our hospitals, but if that's not working, you can also specify your specific values. Okay. So yeah, here I'm just I'm just specifying the virtual IP, node IP. One thing that we are doing now in our team is we are working with single node clusters. Okay. Why is that? It's because in many of the laboratories where we want to install, the machine is already there. Okay, so we took the opportunity to use that machine, install our cluster, but the goal in the future is to use multi-node. Okay, so that's why we are specifying a virtual IP. It will be in the future the IP that users will use to connect to the cluster, but now, as we are using single node cluster, it's the same if you use the node IP. There are other things that you can configure, but let's not focus on this now. And yeah, at this point, it's what I said before. The GitOps creation is triggered, and yeah, it takes some time. So let's continue here. Slide mode. So the next thing that the user wants to do once the cluster is created is download the ISO. Okay. So in the console for the user is as simple as click a button where he downloads the ISO. What's happening in the backend is that our API goes to the database. We get which is the information of that cluster, and then again in the Kubernetes clusters we have in the cloud, okay, in AWS, we create an ephemeral pod where we generate the ISO. And how are we generating the ISO? Talos is providing this imager that you can use. You can use directly the imager, or if you need to do some things in the process of building the ISO, you can also generate your own one based on that. So yeah, a little bit it's a simplification of what we are doing, but what are we doing when building the ISO? We are providing some kernel parameters, okay? So for instance, you can see here that we are specifying the IP, the gateway, the netmask, okay? Also, in the top part, you see that we are using the Talos config. I don't know if you have used it, but when you use Talos config, then it tries to download the machine config from a specific URL that you provide. And then we are also using OAuth for the device flow, the device authentication, sorry. So at this point, we have everything working, but security checked our product and they asked if we were supporting secure boot, and we weren't. So that was a challenge for us. Also, Talos helped us implementing it. So what's secure boot? Before checking what we needed to change, secure boot is a security standard that makes sure that a device boots using only the software that is trusted, okay? And once secure boot is enabled, only the binaries that are trusted can be executed, okay? So what does it mean for us? So it means that when generating the ISO, first we need some keys that we need. You can use Talos CTL to generate that keys, or you can also generate your own ones. And then you need to generate the secure boot assets that you will later use. And then what you need when you create the machine is that first that secure boot needs to be supported, okay, in your UEFI firmware. And what you need to do also, that Talos is doing this magic for you, it's you need to enroll secure boot keys, okay? And Talos is doing it the first time you boot the machine. So here you see in the top part the word changed, okay? So not super difficult. You just need to provide the key information, okay? In our case, we have it in AWS, so that's why we have this AWS region, KMS, key ID, and all of this, okay? And the rest is the same. One interesting thing we saw when you use secure boot is that by default, it's using a confidentiality level, okay? And there are some pods or applications that run on a Kubernetes cluster that may require to read kernel memory, right? That was our case because we are using Tetragon, okay? So in case you want to use secure boot and Tetragon, you will need to modify the lockdown configuration, okay? Instead of confidentiality, you will need to use integrity. Tetragon is checking what's happening in the machine, and we are getting some alerts if someone checks a specific file, for instance, things like this. Then one thing we saw is that you try to install a cluster with secure boot, it's not working because you also need to create your own Talos imager, okay, to be able to install Talos, okay? So yes, so when you have the machine config, you need to install Talos. The imager needs to have also the secure boot keys. At this point, security team was super happy. Okay, so no more questions from security team. And yeah, here I will show you from the user perspective is super simple. So, oops, it was too fast. So here we were creating the cluster, and then what we were doing is just clicking the button in the right, the download ISO. I did the recording yesterday. I don't remember how much time I used to, or I was waiting until I click the button. Okay, let's see. I imagine I was waiting until everything was prepared, okay, because you cannot create the ISO until the GitHub repository is ready. So yes, I just waited some time, and then once you have everything, you can download the ISO, okay. So one interesting thing, let's wait, because there's one thing I want to share to show you. You click here the download ISO, but also what we are doing here, you can also download the Talos config, even the cluster is not created yet, or that does not exist yet, okay? So let's continue with the presentation. Yeah, at this point we have everything prepared in the fleet management, so we can go in the edge location and install the Talos cluster, okay? So what we need to do for that specific case, for that step, it's first we need to configure the UEFI configuration. What we need to do there, three things mainly. We need to enable secure boot. We need to configure the setup mode, which is needed to enroll the keys, okay? And then, as always, just change the boot order to use the external disk, okay? Then the user flash the ISO in the external dish. I see I have here is disk, okay? And then you boot from the external disk. And then what's happening, you see here the diagram in the bottom part. The first boot, where Talos will detect that there are no keys yet, and as we have the setup mode enabled, Talos will automatically enroll the keys. Okay, then Talos will reboot. At this point, it will be already secure boot will be already there. Okay, and as Talos is signed with our keys, it's able to start. And then what we are doing is requesting with the Talos config I don't know if you remember, before I shared one of the kernel arguments we're using, the Talos config. It's with that kernel argument that we are trying to pull the machine config. So how are we using Talos? We use Talos config, and then the problem we have with Talos config is that you cannot authenticate the endpoint, okay? So for that, Talos is providing support for OAuth 2 authentication, okay? So you see here all the parameters we need to specify, and we are adding in the ISO. So the first one is the Talos config. You specify the URL from where you are getting the machine config, and then for the OAuth, you just need to specify classic information, typical information. Two things I want to mention here that are relevant for us or important. You see that we are specifying extra variables, okay, and the UUID and the MAC. Why is that? It's because when we are accepting or rejecting an edge device, we want to make sure that the one that is doing the request is the device that is saying, right? So yeah, that's why we are adding that here. So this is the typical device flow, how it works, okay? So the device app, it's a Talos cluster. It's trying it's doing a request to the endpoint that we have specified. Then the endpoint returns the device code, user code, some verification URL, and then it's constantly pulling, okay, for the access token. And then what's happening at this point in Talos, you will see this information in the Talos UI, okay, that we are waiting for the approval. And then in the browser, what we need to do is first log in there, of course, and then just decide if we want to accept it or not. This is the typical device flow. Okay, nothing special here. So let's see how it works. Let's play the video. Yeah, here I was preparing the Talos config that we will use after it. It's small, but what I'm doing here is export Talos config that it points to the file that I'm creating. And you see that Talos service is not working because there is no cluster there yet. Okay. So yeah, it takes some time to download the ISO. So let's check. Okay, at this point we have the ISO downloaded. Okay. So what I'm doing here is I'm using UTM to create a virtual machine that simulates the edge cluster. Okay. So I explained you how we are using Secure Boot, but for VMs we are not using it. So that's why you will not see that we are enrolling the keys. Okay, because for this specific configuration we are not using it. Here I'm specifying the CPUs, the memory, and the disk we use. That's because by default we provide some platform applications. So that's the minimum that someone needs. And yeah, here some network configuration so I can access the VM. So here what will happen, Talos will boot normally, and you will see how the OAuth request is happening. Okay, so let me pause here. So you see here that we are going, Talos is telling you, OAuth, please visit the URL to accept this specific device, okay? So how we are doing it, we have integrated in our console. So yes, here a pop-up appears in the edge cluster information, so the user can decide if he approves it or not. So that's what I was explaining you before. For us, it's important for production clusters that the MAC is the same as we wanted, and also the UUID. Okay, so then when the user is sure, then he approves it. And once he approves, that Talos config is downloaded. Okay, and magically the bootstrap is happening. Okay, and why I say magically? Because if you check the documentation, you will see that there are two types of machine config, right? Control plane and worker, right? There is a third one that is not documented. I will explain you now, and you should not use it unless you know what is this really doing, okay? But there is one third type called init type that what it's doing is just triggering the bootstrap automatically, okay? So which is the alternative for us? Instead of using this, just using the normal control plane type and then have a separate box in that edge location that triggers the Talos CTL bootstrap. But for us, it's not possible in all edge location. So that's why we decided to use this init type. But yeah, please don't use it unless you know what it's really doing, because the problem with it is that each of the nodes that you install will try to do the Talos CTL bootstrap. So you will have problems with etcd, okay? But for us, as we currently are using single node clusters, it's perfect because then the user can have the cluster without interacting with it, okay? So yes, let's finish the demo I was sharing before. When I was recording it, the internet was not super fast, so that's why it takes some time until Talos reboots. But yes, here in our console, we also store the MAC information, UUID, who approved the cluster, when it was approved, okay? So some metadata that may be useful in the future. And yeah, it takes some time until it's able to pull all the Talos images and then do the normal reboot. Yeah. So here I was just highlighting that it's super fast to create a cluster. So I was going slow, but only in 4 minutes you have the Talos cluster there. And then if you wait 5 to 10 minutes more, you also have all the platform applications ready. So yeah, just the time you prepare a coffee, you have an edge cluster. And yes, at this point, you will see with Talos CTL that the cluster is there. Okay, so I have few more slides before I finish. And at this point, you may be asking that, okay, the process, the creation process is automated, but what about the upgrades? Okay. So what we are doing in the Talos machine config, you can configure this Kubernetes Talos API access. So where you specify there is that, okay, I want to be able to access the Talos API in a specific namespace, okay, and with a specific role. So we are configuring it, so there is a specific namespace there where pods can access the Talos API. And then what we are doing there is we are creating our own image that has basically the Talos CTL binary. And what we are doing there is only this Talos CTL upgrade, okay? Plus some things that we need to do for each of the versions. But the important thing is that we can do it from the cluster. We can trigger the Talos upgrade, okay? One problem we had, it's important that you add this if statement, because otherwise you will be in an infinite loop doing the Talos upgrade and you will break the cluster. And yeah, that's how it works. It's challenging for us because each time we do a Talos upgrade, as we have single node clusters, cluster is not there. In production is not super. Yeah, you don't want to do it because it's like, okay, I'm not sure what's happening. Normally you just wait 5 minutes and then the cluster is up again, but not always is like this. And yeah, that's everything, and I hope you like it. As I said, I tried to focus on the Talos part or how we are using it, but if you have doubts about a specific topic that I mentioned or about how we install applications and how we use GitOps, I can also explain you. Any questions?
Thank you for the presentation. I have a question regarding devices that you roll out that don't have a direct internet connection, so no external IP exposed. I don't see you using Omni, so how do you maintain those clusters?
So again?
If you have a cluster rolled out and it's on a private network in a hospital, how will you connect to the Kubernetes API if you're not using Omni?
There is a feature in Cilium, okay? What we are doing for each edge cluster, we are building a tunnel. So from the fleet management, we have an open tunnel to the edge location, and that's what we use to access the kubectl, the Kubernetes API. Yeah. I think it started being available in 1.13. I'm not sure, but something that you can use if you use Cilium. I think here there is another question.
Hi, and thanks for the talk. Also, you're not the only ones using the init type cluster from the older versions. We're using those too. I'm interested in what do you guys do about firmware updates for like UEFI components? Something that you started working on, because that is something we have been thinking with. It's kind of a dirty minefield of kind of legacy tech. It's not nice.
We haven't checked it yet, to be honest. So something to work on, but we haven't checked it yet.
You explained that you have a GitOps solution and you're aiming towards 10,000 deployments. So how would you maintain applications if you have 10,000 GitOps repos with several application versions? How are you planning towards that?
Yes, so that's also challenging. We have a tool called FoxOps. It's open source, so you can check it. We build it. But at the end, what we have is it's not easy to interact with each of the GitOps clusters because it's not manageable. But what we have is an API over it that you can trigger. So programmatically, you can prepare which is the upgrade package, and then just launch it for 100 clusters, and then it will be done. But that's the goal, to be honest. It's not yet there, but that's our vision. Yeah. For now, what we are doing is for each of the edge clusters, we are doing it manually.
Another question. Check, check. Oh, yeah.
Yeah, it's working.
Since this is like production stuff that when it fails will cost a lot of money, do you have a kind of failover, high availability thing already? Is that something you are thinking about?
So our goal is in the future to have multi-node, so to cover these cases. But for now, we have everything in GitOps. So if a cluster is destroyed, we can.
A new one.
Yeah, it's easier for us to create a new one. And the problem here is the volumes, right? So if the data is only in that node, it's a problem. But if you are using SMB server or whatever, then for us it's easier to create a new cluster than try to fix that. Yeah. Any more questions?
First of all, thank you for the talk. And you mentioned you're using Talos in Docker for development. Do you have homogeneous developer machines, or how's that worked out for you with developers using Windows and WSL, Linux, macOS?
We had some problems with users that were using Windows, and we had a limitation in previous version, I think 1.6 and before, that you can only have one Talos running in Docker for a specific machine. And that was a problem for us because Minikube and Kind were supporting it. What we have now, starting in 1.7, you can have multiple clusters locally, but for our use case, it's fine. But the only problem we have seen is that if you are working in the office, you have the VPN, then you go and work at home. Sometimes the cluster it's broken. So we are happy with it. It covers our use case, but I would say it's not yet at Kind or Minikube state. Any more questions? So thank you very much.